session here, we're going to be addressing the topic of raising to a power. For those of you that have heard of exponents before, exponents are used when we are raising a number to a particular power. Let's go ahead and start off here with the number 2. Here I have the number 2 multiplied repeatedly by itself a certain number of times. Here we have 2 times 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 2. 2 is a factor 8 different times here. Well, in algebra and math, there's a shorthand way of writing this. When you have the same number being multiplied by itself, you can use a shorthand way of writing that. And what you do is you write that as a shorthand using what's called an exponent. But before we write the exponent, the first thing that we need to do is to write down the number that's being repeatedly multiplied against itself. Well, in our example here, that's a number 2. So I'm going to rewrite the number 2 now. Now come back over here onto the left side and count how many times 2 is used as a factor during this multiplication problem. It's used once, twice, 3, 4, 5, 6, 7, 8. 2 is being used 8 times as a factor. So what I'm going to do up here is I'm going to write a smaller number up here and I'm going to raise it. I'm going to raise it and put it near the top of this number here. That's what's called raising to a power. I'm taking 2 and raising it to the 8th power. This number here, that's the number that represents the power that I'm raising it to, is called the exponent. And that'll be listed again for you on the review page at the end of this lesson. So this number here is pronounced 2 to the 8th power. And once again, what that means is 2 is going to be multiplied by itself, and it's going to be used as a factor 8 different times. So if I were to go with the number 6, and I went 6 to the 3rd power, once again, this power that we're raising it to is called the exponent. If I were to break that apart, what does that mean? Well, it means 6 times 6 times 6. We have 6 being used as a factor 3 times. Well, let's say I had 12 to the 4th power. That would be 12 times 12 times 12 times 12. 12 would be a factor 4 times. 1, 2, 3, 4. So using exponents is a shorthand way of being able to write down a particular repeated multiplication problem. And remember, with multiplication earlier, we talked about multiplication as being thought of as repeated addition. Well, in this case, when you raise a number to a certain power, you're talking about repeated multiplication. What's the repeat? Well, in this case here, the repeat is that 2 is being repeatedly multiplied by the number 2 itself. So when you raise a number to a power, you're repeatedly multiplying it by itself. And just to quickly show you maybe a little bit of difference here or contrast, here once again we have 6 to the 3rd power. That equals 6 times 6 times 6. But if I were to come over here and write down 6 times 3, what I'm contrasting here is this 6 times 3 with 6 to the 3rd power. Here, 6 times 3 is 18, but remember it's repeated addition. So it would be 6 plus 6 plus 6. That's a simple multiplication number representing repeated addition. Well, here is a simple number problem with a number that's being raised to a particular power, and what that means is repeated multiplication. The same number used as a factor 3 times. Over here, the same number being used as an addend 3 times. Okay, on the next screen here, let's take a quick look at a couple different things. Once again, whenever you raise a particular number to a power, you simply pronounce it as the number raised to a power. So for example, let's start here at the bottom. 2 with an exponent of 5. That means 2 to the 5th power. 2 to the 5th power. Okay, we'll come up and take a look at 2 with the 4 exponent. That's 2 to the 4th power. Well, you can do the same thing with 3 as an exponent and 2 as an exponent. You could say 2 to the 3rd power. That's accurate. You could also say 2, for this number up here, 2 to the 2nd power, because that's our exponent, 2. But there's also 2 special names given to an exponent that has a 2 in it, and another one that's given an exponent of 3. 2 to the 2nd power is the same thing as 2 squared. And the reason for that special name is, remember, in a multiplication problem, another way of thinking of that multiplication problem is to think of a rectangle, and that the rectangle has sides that have the length of the 2 numbers that are being multiplied together. Well, in 2 to the 2nd power, what are the 2 numbers that are being multiplied together? Well, a 2 and a 2. Well, what type of rectangle has a length and width of the same length? Well, a square does. A square is a special type of a rectangle. Well, since a square has both lengths the same side, same dimension, the same value, and here 2 times 2, giving us the same value, 2 to the 2nd power is just also called 2 squared. And following along the same reasoning, here you have a cube, and the volume formula for a cube is length times width times height. Well, in a cube here, the length, the width, and the height are all the same number. 2 times 2 times 2. Well, over here, 2 to the 3rd is the same thing as 2 times 2 times 2. And since that can be used to illustrate the 3 lengths of a cube, length, width, and height, they give a special name to 2 to the 3rd power, and they also call it 2 cubed, because cubed representing that a cube with the same dimensions of 2, 2, and 2 work out to give you the volume of that cube. So don't get confused by it. 2 to the 2nd power is also 2 squared. 2 to the 3rd power is also 2 cubed. But 2 to the 4th power, 2 to the 5th power, and each of the subsequent exponents would be to that same power. So 2 to the 111th exponent would be the same thing as 2 to the 111th power. Once again, down here, just refreshing your memory about the difference between multiplication and raising a number to a power. 2 times 5 is 10. However, 2 to the 5th power is not 10. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 2 as a factor 5 times. Well, what is 2 times 2 times 2 times 2 times 2? Break it into parts. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So what's 2 to the 5th equal? 2 to the 5th equals 32. And if we took x squared and broke it apart, it would be x times x. X is a factor 2 times. That's what our exponent there tells us. So don't get confused by seeing a variable being used as part of an exponent problem or raising a number. You just simply repeat it. X to the 2nd would be x times x. X to the 5th would be x times x times x times x times x. Lastly, this is a quick review. An exponent tells you how many times a particular number is repeatedly multiplied. Okay then, that'll finish up session 6 on raising to a power.